Let's now watch the demo of the propeller board doing parallel processing using the 8 cores that it has. So I have the propeller board here, and the program has already been stored in the external EEPROM. And this is the propeller chip here. And I'm using a 9-volt battery to power up the propeller board and the external interface circuits, which is the LED, and this is the push button switch to be able to control the program. Okay, so I'm gonna turn on first the 9-volt battery, and what's gonna happen is that the program in the EEPROM are then transferred to the main RAM in the propeller, and then it would also cause the processor 0 to start running, which then lights up this LED as an indicator that processor 0 is running. So every time the main program is uploaded and run, the main program is always being processed on the processor 0. So you're going to see it light. Then I'm going to be able to use this switch to be able to control and start a processor to start processing each of the LED blinking tasks. Okay, so first I'm gonna turn on the 9-volt battery here. It typically takes about 2 seconds for processor 0 to start running after uploading the program from the EEPROM to the main RAM of the propeller. So now the program is waiting for the switch to be pressed. So depending upon the amount of time it's going to be pressed, that the LED would also be blinking based on the duration that the switch has been pressed. So if I, let's say in this case, just switch it quite fast. So now what happened was that the main program sent a task to, let's say, processor 1 to blink based on the duration of the button press. So again, the main program, it goes back again to the main program. And so we now have, still processor 0 running, processor 1 running, executing the LED blinking. So in this time, let's say I press on the button quite for a long time and then release it. And now you see that the processor number 2 is now processing the LED blinking task, and the duration was dependent upon how long I pressed the switch. So it took a few seconds for me to do that, and so it's blinking at a slower rate. So we now have 3 of the processor running, and again the main program is still waiting for me to press it. So if I press it again, so now I have processor number 3 running, and now we have 4 tasks: the main program, LED blinking 1, LED blinking 2, LED blinking 3, all running in parallel simultaneously. Okay, and so I keep on pressing it again. So you now processor 4, processor 5, processor 6, and the last one, processor 7. So you've got all 8 processors running simultaneously, all at the same time. And again, with the use of this switch, I could eventually be able to stop any of the processor from running in order to save power. So for example, if say, okay, I'm done with the task here with processor 7, I could just turn it off and then keep on doing that until I turn off all of the processor. Of course, processor 0 will always be running because it's running the main program. And then once all processors is off, I could repeat the same sequence again. I could, press the button and start, causing LED blinking to be executed by processor 1. And then another similar task being called on by starting let's say processor 2. So it's so easy to be able to start and to stop, a processor from running a new task or stopping from executing an existing task and so on. So that's the beauty of the parallel processing capability of the Propeller board or the Propeller MCU in terms of having 8 processors in the chip. And so with this, we could see all of the 8 processors running simultaneously at the same time. Okay, so that's it, and hope you enjoyed the demo.